Good morning, everybody, and welcome to today's G2M research webinar. Today, our topic is cloud service providers. Is public cloud, private data center, or a hybrid model right for you? Now, let's jump into the subject. So I'll go through the ground rules a little bit here in the agenda. So one thing, this webinar is being recorded. We will make that recording available to everybody who registered. It'll take about 2 days, so think Thursday or so you should be getting an email from us with a link to the recording as well as a PDF of the slide set if you register for the webinar. A couple other things, we'll have a couple poll questions during the Q&A session. So we'll go through a panel discussion first. Both of our sponsors will present for about 10 minutes each. Then we'll go into 3 panel discussion questions, which we'll show and then the panel will answer. Followed by that, or in between those, we'll have 2 audience survey questions that you can answer using the Zoom poll capability. And then we'll have Q&A. So you can submit Q&A questions at any time. Just use the Q&A window in Zoom. Put your questions in. When we get to that part, we'll go through the questions and answer them one after the other. So with that, let's go ahead and get started. So just for a reference standpoint, one of the questions we always like to answer is, what does a cloud service provider mean in the context of this webinar? So for us at G2M Research, a cloud service provider is somebody who provides a software as a service offering to a variety of customers. You can think of people like Salesforce, Dropbox, Limelight, Akamai, NetApp, like NetApp Cloud, for instance, SAP, they have a cloud offering. Twitter, these are all platforms that are built to deliver a specific service or a set of services. You know, those things could be CRM or marketing automation, e-retail, content delivery, or email and storage. Obviously, for companies like this, some of their greatest costs are the actual infrastructure itself, the computing, the storage, and the networking. So a lot of these companies, as we all know, start out running on the cloud. But at some point, most of them start to look at the costs of running a cloud and say running their own data center might be cheaper. In a lot of cases, they'll mix in cloud resources for peaks or overflows or for long-term storage or things like that. So that's kind of what we're looking at from the definition of this webinar. So if you think about storage, which is the particular focus of the webinar, you've got a lot of challenges when you're trying to when you're trying to field a cloud service provider offering. Usually a lot of these have huge amounts of data. Facebook, which you could consider a cloud service provider, probably the largest one, has huge amounts of data, right? Peak bandwidth that they have to be able to pull data off could easily go over 1 terabyte per second. In most cases, a lot of these guys have millions of concurrent users. Think of somebody like Salesforce.com or any of the other ones. You might have a lot of users hitting that data all at the same time. And usually, because you want to be close to your customers, you want to spread these across multiple data centers and or cloud resources so that the distance from wherever that point of presence is to your customer is minimized, speeding up performance. And that's true whether it's a cloud-based data center or on-prem data centers. So if you think about a lot of the key drivers, which we'll talk about in this webinar, their ability to scale rapidly the number of users. That's certainly one of the reasons people go to the cloud. Bandwidth and capacity. Minimizing CPU utilization, right? If your CPU is serving up storage, it's not running the application that you're charging people for. Minimizing power footprint. Obviously, power becomes more and more of an issue, both from the standpoint of paying for it as well as the cooling and getting rid of that heat. And then providing predictable end user performance. You think, especially in e-retail situations, if it takes a while, or even or even things like content delivery networks, you may go to another source if it takes too long to get your transaction completed. So that's really important as well. So let me introduce our panelists. First, we'll have Saji Grimberg. Saji is from Lightbits. He's the Chief Technology Officer. And then he'll be followed by Clint Stalker, who's Director of Business Development at Netlist. And my name is Mike Hume, and I'm the Principal Analyst for G2M. And with that, Saji, let me give you control, and you can go ahead and drive.
Okay, thanks, Michael. So I'll talk about Lightbit's storage solution and why it makes sense for cloud providers or different cloud deployments. And LightOS is a high-performance, scalable NVMe to TCP storage service. And the slide should,
There we go.
okay, it's not appearing here. Okay, I have quite a delay. I'm sorry for that. But I do have a delay. I'm not sure exactly which slide I'm on.
You're on your title slide now.
Okay. All right. So let's move one slide forward. So the Lightbits product is called LightOS, and that is essentially a scale-out software-defined storage solution that is based on NVMe over TCP and offers a combination of high-performance flash management and rich data services. The solution is distributed, highly available, and simple to manage and scale. Now, if we look at the diagram here, we have compute servers on the left hand, which are all based on standard in-box software, running workloads on bare metal, containerized or virtualized environments, and support NVMe over TCP natively. Examples for containerized environments is obviously Kubernetes, virtualization, we have VMware, most recently in OpenStack, and equivalents. Now, these applications that are running on these environments consume storage over the data center network, which is always or almost always Ethernet TCP IP. And on the right-hand side, we have the storage cluster, which is disaggregated and powered by the LightOS software. These are standard x86 servers with standard NVMe SSDs and standard Ethernet NICs, preferably high speed. The LightOS software is a set of packages that's deployed on them, clusters these servers together, and form an aggregated pool of NVMe TCP flash storage that's high performance and highly available. Okay. Okay, so one thing that we provide is infrastructure as a service flexibility and the ability to scale storage independently from compute. You can scale it up, scale it out, or do both at the same time. If you look at the left-hand side, we have on a per storage basis, you can start with a partially populated system. Start small, what's known as starting small, and then add either single SSD or a batch of SSDs at any point in time. And the system, without any disruption, will automatically expand the capacity of the cluster and will start occupying the space with the log rotation of our flash management system. On the right-hand side, you can also scale out the cluster. So we can start with a minimum of 3 nodes or 3 storage servers, and additionally add server or a batch of servers to the cluster at any time without any disruption, and all the workloads will start enjoying the expanded capacity and performance depending on how you configure the server. The cluster will automatically and dynamically rebalance the data to spread out both capacity and load to achieve optimal capacity utilization as well as performance. Okay, so besides being a flexible scale-out system, what we deliver is really NVMe over Fabric speeds, but with data services that are we got used to know and love from the traditional arrays that have been used for decades and decades. So our cluster exposes to the compute host is really NVMe over TCP virtual block devices. These virtual block devices are thinly provisioned. We have inline compression to perform data reduction We have SSD level RAID on a per RAID group basis. You can have one or more per enclosure, as well as HA policies on a per volume basis, depending on how much you need the volume to be available. Today, we support a synchronous replication. In the future, we'll do distributed erasure coding. And now, an important features for cloud service providers are the ability to take volume snapshots and clones. Implementation is redirect and write, so no extra capacity is being occupied when taking snapshots or creating a volume or a clone from a base snapshot or volume. Volumes can be resized online without any manual intervention to expand the capacity for the specific workload. And really all of that and more with premium performance and consistent low latency that enterprise workloads require. Okay, so we mentioned LightOS flash management in a word, but in essence, what we build is a full-blown flash translation layer, which is very much aware of the underlying flash characteristics, and hence built for QLC flash, and that helps our customers reduce TCO and achieve cost efficiencies that they could not have done before. QLC basically means more density on a per NAND cell, 4 bits, which is an improvement from the last state of the art, which is TLC. So that allows for cost optimizations, more capacity at a lower cost. And the sacrifice is really endurance and performance as a result, as the program erase cycles are really deteriorated with the introduction of the technology. Now, the LightOS flash management or global flash translation layer, the operation takes over the majority of management tasks, leaving the underlying NVMe drives handling a very comfortable and predictable access pattern, which results in a better performance and endurance. And the global flash translation layer that we implement takes care of sequentializing writes and log append, I/O scheduling, SSD level RAID, cold data detection, and data services that we mentioned before. So with LightOS, basically we enable QLC flash and make it applicable for tier 0 enterprise workloads. We basically improve the endurance of up to 20 times with the flash management operation in combination with data reduction. That allows for high capacity and high density form factors at a low cost and still meeting the performance requirements that we shine on. Now, the way that we do that, if we look at the reference diagram here, we make use of all the memory or storage components for a specific need. First, we have our QLC flash pool, which is on the right. That's our primary storage. And with our flash management, high availability capabilities of our solution, can support on every enclosure very high density, hundreds of terabytes or north of half a petabyte on a per 2U enclosure in some cases. And that's raw flash capacity. And that is all RAID protected on a per RAID group basis. And that means that we can stand to lose a subset of the capacity of the enclosure without incurring cluster-wide data movement, which allows our systems to be very dense. Next, we have the system memory. That's the DDR here on the bottom. That's small in size. That's used for boot, operating system image, normal operation, primarily for data path I/O staging buffers. The majority of this system memory is Optane DCPMM, which we use in app direct mode and has 2 roles. Number 1 is persistent write buffering. That's our journaling system that we acknowledge writes, persist them consistently and coherently across the cluster as we stage the data for write back processing by our flash management backend. That is a small size, just few gigabytes, and it's designed to be persistent memory, but not more. The majority of the Optane memory in the system, that's used for a granular log structure metadata store that we use for fast lookups. We can support up to terabytes of capacity in the system, and we don't need that to be non-volatile as we persist our metadata with the stripes themselves in log append. So that's actually a cheap replacement or cheap alternative to system memory. Allows us to reduce the cost further. So if we sort of recap, LightOS offers capabilities for different cloud use cases. For customers and enterprises that build their own private cloud, offer software-defined solution that follows the best practices on how we want to build this private cloud. It's very simple to manage and scale. Delivers high performance for to meet pretty much all of the enterprise cloud workloads. With rich data services that are very, very relevant for the private cloud, and reduces TCO with our support for QLC. For cloud service providers and infrastructure as a service providers, the LightOS software solution is highly available, meaning that the CSP users will not suffer a lack of availability from their storage service. It's very easy to scale with the customers and with the additional users of the platform. It's multi-tenant aware, which allows every tenant to be isolated from each other and be exposed to only the resources that is allowed to manage. In addition to QoS capabilities, and it integrates into the framework of choice of most of these cloud service providers: Kubernetes, VMware, OpenStack. These are classic infrastructure as a service providers. For the edge, the capabilities of fail in place, meaning that as systems from the cluster keep failing, the cluster will remain available and rebalance and restripe data in a way that will make optimal use of both performance and capacity. As being software defined, we support a wide variety of deployment and form factors, and standardization around operating systems, standard networks, standard SSDs without any niche proprietary array-like solutions. And for the public cloud, you'd have to stay tuned as our product offering will evolve in the future. And I think with that, I'm finished in this section, so I'll give up remote control.
Perfect. Thank you, Seji.
Thank you.
Let's go to Clint Stalker. Clint is with Netlist. Clint, you should have control now.
I think I'm done after what Saji just presented. I mean, Saji did a great job of talking about system memory and primary storage, but no, I say that in jest. So good morning, everyone. Good afternoon and good evening for folks around the world. I'm requesting control here.
Should have control. I can flip them if you can't get it though. Just move your mouse around, see if it moves anywhere. I don't see it. There we go. It says you're controlling it now. There you go.
All right, moving forward slowly. So I work for Netlist, Director of Biz Dev. And what I'm going to be talking about, and a lot of what actually Saji was just talking about, is system memory and primary storage. So we'll come from the world of NVMe SSDs. So Netlist, publicly traded company, been around since 2000. Started off as a DRAM module maker, started off in the embedded flash world. And over the past 21 years, we've evolved. We've gone from talking about compact flash, the inventor of the RDIMM, Years forward, we've included advanced logic and firmware innovations on our DRAM modules to actually include NAND and logic on our DRAM modules. And a lot of what we're going to be talking about today is actually going to be enterprise NVMe SSDs. So Netlist, we've been around, we have a portfolio of patents for server memory, hybrid memory, storage class memory, rank multiplication, load reduction. But again, in the world of enterprise SSDs and specifically NVMe SSDs, which Saji was talking about a lot, is where we're talking about. So when it comes to NVMe SSDs, latency is probably one of the primary factors for cloud service providers. Latency can be response time, wait time, what have you. It can be the amount of time to perform a stock trade. For our kids loading Fortnite on a SQL server, completing your Amazon purchase. So NVMe is the leading storage technology to enable top performance. Customers are migrating to NVMe SSDs for faster processing and bandwidth. And it's critical because customers can't wait. Gaming service providers are migrating to 800G servers for their clients. Video streaming service providers, which were referenced at the beginning of this presentation, talking about 400G servers. CDN systems are going to all flash arrays for payment processing. And as you can see from my subtle picture there, self-driving cars. Latency is key when it comes to this world. So latency affects the bandwidth as more IoT devices become connected. So be it your app on your phone, your transaction, on a Friday night when there's a boot storm going on and everyone wants to watch the latest Stranger Things or what have you. This is what latency is key, and this is where the NVMe storage comes into place. Per SNIA, latency is the most important metric for performance and sensitive application and database environment. So when we're talking about private cloud, public cloud, hybrid cloud, multi-cloud, SSDs, what's important here is SSDs with consistent and predictable performance. So high quality of service, be it 4 nines, 5 nines. You can't have your high latency spikes. You need predictable and consistency. These are the necessities. So the information needs to be located at the edge with the cloud and the data center behind it. So similar to what Saji was talking about, the hybrid model. So you need to have your devices at the edge with something at the cloud to back it up. Data needs to be stored closer to customers so the data packets don't have to enter the cloud where the congestion is high. Congestion is high again. We're talking about Friday nights when everyone's downloading a Netflix movie or kids are playing their Fortnite games. And this is where the local points of presence are key. So localization is a focus when it comes to data processing. So when it comes to the world of Netlist and our expertise in NVMe SSDs, we have best-in-class performance, high capacity devices, high endurance devices, short lead times, on-hand availability, readily available devices for samples as well. So of course here, I'm going to show you a nice little marketing slide on how we stack up against the competition. And when it comes to this world, in the world of Gen 4 NVMe SSDs, sequential writes, random reads, we excel. So for anyone on this call, last I saw there were 60 odd people, and hopefully some other folks are going to be checking out the recordings later. I welcome you to reach out to us, sample our drives, test our drives, take the Pepsi challenge with us. Our devices are real and our performance is excellent. Beyond our own individual lab testing, we've actually had third-party lab testing as well. So when it comes to SQL Server, Sysbench, VDBench, against the competition, we've had both synthetic testing as well as application level testing. As many folks on the line probably recognize, Real world testing is paramount. Synthetic testing is nice because it can be consistent and replicated in different types of environments, but ultimately what matters is your own environment. So in actual application level testing, latency here as an example, versus one of our competitors, the latency was 5 times higher in a VM environment. So this is real data validated by a third-party lab. Even in synthetic testing, application level testing is also 2x what we're showing here. So when it comes to the devices that Netlist manufactures, we're talking solid state drives, be it enterprise class, data center, hyperscale. We also have embedded flash drives, like be it your CF cards, SD cards, embedded USB, M.2 drives, as well as DRAM modules. So again, kind of similar to, again, Saji helping me set up for the world of system memory and primary storage. This is our world. And as I warned Mike and Saji at the beginning, I had an espresso and a Red Bull. So I went pretty quickly through this presentation.
No worries. All right, with that, let's go ahead. I'll grab control, Clint. All right, let's go ahead and go to the panel questions. So this first question will have Clint answer, and then we'll have Saji answer after that. And the question is, what are the top 3 drivers for choosing whether to put your primary storage in the cloud, on premises, or in a hybrid model?
So when I'm responding to the question, so please keep in mind that I'm approaching this as a storage component supplier. So we're making the drives, not the servers or the storage appliances. So given that there are a bazillion use cases out there, there's no one size fits all type of solution, but there are several factors that are taken into consideration. First one I'd probably put out is pricing. Cloud storage is generally less expensive from a TCO. Obviously, scalability affects compute and storage resources. Data security would be a second factor. So for cloud storage, you're entrusting the management of your data to another party for them to manage and keep secure. Lastly, performance. So this is where we have been talking about a lot when it comes to play with CDNs and a lot of the examples you provided at the beginning of the presentation, Mike. Hot data is localized at the edge where the data is backed up in the cloud. Predictable, consistent performance is paramount, especially with scale.
Perfect. And Saji, what would you say are the top 3 drivers driving these choices?
Okay, that's a good question. I think that the main consideration ultimately depends on what the business needs and where the business is at this particular point in time where you need to make the decision. For example, if you're a young company that's just starting out, probably the cloud will be a very easy choice to go for because it's all readily available. You really consume what you need at that moment, and it's very easy to support growth without the hassle of planning capacity and planning growth ahead, which is an art form and not one that's easy to master. But I think that at a certain scale, it will be much more cost effective for many workloads to move on premises, where you have more control over what you buy, what you deploy, and how you deploy it in terms of what these workloads need to achieve. And I think that if you're an established business that wants to expand to new territories or to burst, probably the best practice is to go hybrid. That's at least what we see from talking to customers.
Excellent. With that, let's go to the first audience survey question. And this should show up on your screens. The question is, what do you see as the greatest trade-offs between on-premises storage, cloud storage, and a hybrid model? This is a pick one answer sort of thing. We'll give you about 2 minutes to answer this question. While we do, we'll go to the second panel question. That question, we'll have Saji start this time, is many hyperscalers now offer cloud-based instances of technologies such as NVMe, NVMe over Fabric, and clustered file systems. How can you best integrate these capabilities into a hybrid storage model? Or does it even make sense to?
Yeah, it does. And I think that the important point is that whatever solution of choice, it must have a standard interface and preferably with a well-established ecosystem. Something that these hyperscalers or the consumer can integrate with and have continuity of the business regardless of the specific solution that it chooses. And preferably these solutions are supported in box on bare metal, virtualization platforms like VMware, container platforms like Kubernetes. The ease of use and a single click and play experience is very, very important. And having a solution that allows portability of your workloads, that is sometimes a key factor to enable a hybrid model. So probably the choice would be to go with a software-defined solution that allows for both your storage service, your NVMe over Fabric service to move along with your application, regardless of which infrastructure is running on.
And Clint, what would you say on this one?
So again, approaching these questions as an NVMe SSD supplier, excuse me, NVMe SSDs are typically where the hot data is stored for your quick and consistent responses. So you have latency, IOPS, bandwidth are critical here. Additionally, as we're seeing here with 8, 15, 30 terabyte NVMe SSDs, the edge is not just lower capacity devices these days. So capacity is definitely trending higher. As with the companies that we were mentioned at the beginning of this presentation too, I mean, the latest tweet or the hottest movie that resides at the edge of the NVMe SSD, whereas the older tweets and less popular movies are considered cold storage and likely reside on HDDs or a third party like an AWS. Similar to light bits, we're also seeing NVMe over Fabric replace DAS in the cloud and data center infrastructure. So using NVMe throughout the data center simplifies the design and improves the deployment costs. Lastly, when it comes to the clustered file system topic, our drives are file system agnostic. So one thing that should be considered when designing your systems is redundancy needs to be taken into consideration in order to avoid any single point of failure.
Very good. And with that, let's go to the second panel question. Oops, sorry, I went a little too far there. Or the second audience survey question. That question is, what are the biggest impacts of maintaining an on-premise data center as a cloud service provider? Let me go ahead and launch that again. We'll give you a couple of minutes to answer these. Go ahead and answer them in the window. And with that, we'll go to panel question number 3. And panel question number 3 is, how can storage data sets be effectively managed in mixed environments? And Saji, we'll start with you and then go to Clint.
Yeah, I think it's, again, touching on having a consistent interface and a standard normalized infrastructure is key. That allows workloads to be portable. And once you achieve that, your workload can run wherever with the infrastructure completely transparent to the workload. And having applications stretch in these mixed environments and be able to move is really key to how you can effectively use and manage these databases. We can think of cases where the workload can access the data set on premises, leveraging the cloud for backup or disaster recovery, or run natively in the cloud, again, using either the cloud or an appliance for disaster recovery. But what's important is that the data set can be stored statically or move what needs to have or what we need to have is a consistent, normalized infrastructure and interfaces that allows us to run exactly the same thing, regardless of where we run it.
And Clint, what do you think about this question?
So, I mean, tiered storage is certainly a gigantic aspect to this. So, I mean, be it hot and cold data, the wheres and the whens. There are methods for drives such as deduplication, compression, but realistically, the most effective method is having real-time access to the performance data. And I think this is where software comes into play. So this is an area where I'm going to defer to the experts at the likes of Lightbits here.
No worries at all. So with that, let's see, do we have any questions? It looks like we have no questions. So we have no Q&A questions. So just to wrap things up really quickly, again, thank you everybody for joining this webinar. We'll send out the link to the recording and a PDF of the slides by next Thursday. Everybody who registered should get one of those. So again, if anybody has questions, you can put them in now. We'll give you a couple of minutes. And if not, we'll wrap it up and give everybody 30 minutes back or 20 minutes back of their day.
I think there's a question in the chat window.
Here's a question. Okay, this question is, I have a question for Clint Stalker Netlist. When they launched the CXL hybrid DIM model, and how much could this market be worth in the next 5 years?
So I don't have the number with regards to the market within the next 5 years. As I'm guessing you're gathering, we are developing a CXL device. Please contact me directly, and I'll gladly discuss this fun stuff under NDA with you.
Yeah, I think the hybrid DIN market is one that we've been looking at for a long time, and obviously there's some use cases coming up now that are making more sense, actually in some of the markets we're talking about in this webinar. So I wouldn't be surprised to see it grow significantly, I guess would be my look at it. Do you have any feel on this one, Sajid, as far as hybrid DIM goes, or its part in the market?
I definitely think it has part in the market, especially for solutions that that have their own memory hierarchy, leveraging different interfaces, both memory and storage, and are designed to deliver a high-speed performance. So I think that CXL will be very, very applicable for these sort of systems. We are looking at them as well. As for what the market worth will be over the next 5 years, that's something I don't know if I can answer though.
Yeah, I think that one's definitely a crystal ball exercise. There's a lot of people have a lot of different opinions on it. So I guess we'll see as the market matures and see where it goes. All right, if there's no other questions for Q&A, again, thank you everybody for joining us. We'll send you a link to the recording and a copy of the slide set. Thank you, Clint and Sajid, for sponsoring the webinar and participating as panelists. I think your insights were really good. And again, I hope everybody has a great day. Thank you very much.
Thanks, Mike, for setting this up.
Thank you.
Take care, Sajid.